This is measurement video number 4. We're going to look at temperature scales, percent error, and density calculations. You're going to need a calculator as well as a reference table. So if you don't have those, you might want to just pause the video real quick and go get them. The two temperature scales that we're going to be looking at this year are Kelvin and Celsius. So the Kelvin will be represented with a symbol capital K, and Celsius has a degree C sign. Notice for Kelvin there's no degree sign. So here's a picture of the thermometers side by side showing you Kelvin, Celsius, and Fahrenheit. Although we're most comfortable and familiar with Fahrenheit, we're going to mainly be converting between Kelvin and Celsius scales this year. There are two fixed points on the Celsius scale, 0 degrees Celsius, which represents our freezing and melting point of water, and 100 degrees Celsius, which represents the boiling point of water. So the Celsius scale is based around water. What's interesting about the Kelvin scale is that the lowest possible number is 0 on the scale. So absolute 0 is very, very cold. The 0 point on the Kelvin scale you could fill in your note packet here is absolute 0. And then in the bottom of your packet, I just would like you to fill this in. Kelvin, Celsius equals K minus 273 and K equals C plus 273. I would box this one over here, the K equals C plus 273. This equation also appears on your chemistry reference table. So on the very back of your reference table, you could flip it over. This is the very last equation in your reference table. It says K equals C plus 273. It tells you what kelvins are and it tells you what degrees Celsius it are. As far as information about the temperature scales that you should be familiar with, you should understand that water boils at 100 degrees Celsius and freezes at 0 degrees Celsius. And we should know what those numbers correspond to on the Kelvin scale. Since Kelvin we know is Celsius plus 273, the freezing point of water, since 0 in Celsius is just 273 higher, 273 Kelvin. And water boils at 100 degrees Celsius, so if we were to add 273, we get 373 Kelvin. In your notes, there's 3 examples that I'd like you to try using the equation on the back of the reference table, K equals C plus 273. Just to get you started, example 1 tells you the body temperature is 37 degrees Celsius. So in the degrees Celsius spot, you would put 37, and then you would just add 273 to get the Kelvin temperature. So in your equation, whenever there's a number in front of the degree C, like in this case 37, it goes in the degree C spot. If you were given a number in front of the K, that would go in the K spot in the equation. So at this point, pause the video and try examples 1, 2, and 3. Now that you've finished, I'd like you to look at the next equation on your reference table that we're going to be looking at, percent error. If you notice, percent error is equal to measured value minus the accepted value over the accepted value times 100. So here's where the equation appears on the back of table T. So if you can copy this equation right into your notes in the percent error spot, there's a blank. The example says, a student determines the density of a substance to be 1.54 grams per milliliter. The accepted value is 1.59 grams per milliliter. Calculate percent error. So from the reading, it says that the accepted value is 1.59. So that's going to go in the accepted value spot in the equation. The measured value is what the student found. They measured the value to be 1.54. So your setup would be 1.54, which is the measured value, minus the accepted value, which is 1.59, divided by the accepted value, 1.59 times 100. When you plug that into your calculator, you get -3%. If you notice, percent error can be negative or positive. We're going to take the absolute value of the numerator to just figure out how much error we have. We're not concerned with if the value that we got was greater than the actual value or less than the actual value. We just want to know the amount of error in the measurement. If you could also try this question about my dog Dexter, and we could figure out how much error we have in the question. Next, I'd like you to look at the density equation on the back of the reference table. This one is the first equation that appears on the top of table T. So here's our equation, D equals M over V. Table T also tells you what D stands for as density, M is mass, V is volume. Looking back at our notes, the units for mass in a problem are usually going to be given as grams, kilograms, or milligrams. And the unit for volume in a problem will typically be in liters, milliliters, or centimeter cubed. It's important to note the centimeter cubed because it may not be obvious that sometimes we're talking about the volume of a solid. Remember that when you're a little kid and you're learning math, you start to learn volume as length times width times height. If we're looking at an object and we're measuring with a centimeter ruler, centimeter times centimeter times centimeter gives us the volume as centimeter cubed. So since density is the mass divided by the volume, density will be given as grams per liter or grams per milliliter, typically in a question. We're going to talk later in the year about other factors that affect density. So, for example, temperature and pressure. We'll leave that for later, though. Next, I'd like you to look at Table S. Table S has a listing of elements. I do want you to know that for the elements listed in Table S, densities are listed. So take a second to find the density of copper and find the density of lead. To find Table S, that's the one right before Table T. Since Table T is the very last page of the booklet, the reference table, you could start from the last page and open up. It looks like this. It has a big listing of all the elements and their densities are listed all the way over here to the right. So on the left-hand side, you look up what the element is and then go over and read what the density is. So take a moment to do that for copper and lead. Tomorrow in class, we'll go over the values to make sure that you found the right numbers. And that concludes the end of video 4.